Look at a clock, any clock. The one on your wall, the one on your phone, the second hand, ticking away right now. Something about that ticking feels absolutely certain, doesn't it? It feels like the universe is marching forward, one moment at a time, dragging you along with it. The past is gone. The future hasn't arrived. And right now, this precise instant, is the only thing that actually exists. That feeling is completely natural. And according to physics, it is almost certainly wrong. I want to talk about something that most people think they understand but actually don't, and that thing is time. Not time in the poetic sense, not time as a metaphor for aging or loss, but time as a physical dimension of the universe, as real and as geometric as length, width, and height. Because once you actually understand what physics says about time, something remarkable happens to the way you think about almost everything, including the beginning and end of a human life. Let's start with something simple. You're sitting in a chair right now, and you feel completely still. But are you? Well, the Earth is rotating. It's also orbiting the Sun. The Sun is orbiting the center of the galaxy. The galaxy is moving through the local group of galaxies, which is itself moving through the universe. So you, sitting perfectly still in that chair, are actually screaming through space at hundreds of kilometers per second in multiple directions simultaneously. You don't feel it because everything around you is moving with you. Your sense of being still is completely local, completely relative to your surroundings. Now here's where it gets interesting. Einstein realized something almost 120 years ago that most people still haven't fully digested. He realized that motion through space and motion through time are not two separate things. They are two aspects of the same thing. You are always moving through space-time, and the total rate at which you do so is always fixed, always constant, always the same for every object in the universe. The speed of that motion through space-time is exactly the speed of light. Now hold on, because I know what you're thinking. You're thinking, I'm not moving at the speed of light. And you're right, not through space. But through time, you absolutely are. When you're sitting still, not moving through space at all, every single bit of that space-time motion is being directed through time. You age, you tick forward, you experience the full flow of time. But the moment you start moving through space, some of that motion gets redirected. You slow down through time. Your clock ticks a little slower. Your aging slows a little. The faster you move through space, the slower you move through time. And if you could somehow reach the speed of light itself, time would stop entirely for you. This isn't philosophy. This has been measured. Atomic clocks on airplanes tick slower than identical clocks on the ground. Clocks on GPS satellites have to be corrected constantly because they run at different rates than clocks at Earth's surface. The effect is small at everyday speeds, but it is absolutely real, absolutely measurable, and it fundamentally changes what the word now means. Here's the problem with now. You probably think that right now, at this very moment, there is a single universal present that every object in the universe shares, some kind of cosmic moment that everything participates in simultaneously. But that idea, as comfortable and intuitive as it feels, is not supported by physics. Imagine two trains passing each other, one going east and one going west. Someone in the middle of the eastbound train lights a match at the exact moment the two trains pass. Now, from the perspective of a person standing on the ground, that light from the match travels outward in all directions at exactly the same speed. So it reaches the front and back of the eastbound train at different times. Because the train is moving, so the back end is moving toward the light source and the front end is moving away from it. The person on the ground sees the light hit the back of the train first. But here's the twist. From the perspective of a passenger sitting in the middle of the eastbound train, the train is not moving. They are sitting still. And the light travels outward in both directions at the same speed and hits both ends of the train at exactly the same time. Two events that are simultaneous, according to the train passenger, are not simultaneous, according to the person on the ground. Both observers are equally right. There is no single correct answer about which events happen at the same time. Simultaneity is not absolute. It depends on the motion of the observer. This is not a trick or an illusion. It is a deep feature of the physical universe. Einstein called it the relativity of simultaneity, and it completely destroys the idea of a universal now. Different observers moving at different speeds will genuinely disagree about which events are happening at the same moment. The disagreement is not a mistake. It is the correct description of physical reality. So what replaces the idea of a universal present? The answer that physics gives us is something called the block universe, or sometimes called the eternalist view of spacetime. And this is where things get genuinely extraordinary. Instead of thinking of the universe as a three-dimensional space that changes over time, think of it as a four-dimensional solid object. 3 dimensions of space, 1 dimension of time, all woven together into a single geometric structure. In this picture, every event that has ever happened or will ever happen already exists as a fixed location in this four-dimensional block. The Big Bang is one region of the block. What you had for breakfast is another region. Tomorrow morning is another region. Your birth is a location. Your death is a location. Everything is there, laid out like a vast, eternal map. Now here's the thing that trips people up. If all of spacetime is a fixed geometric structure, why does it feel like we're moving through it? Why does it feel like time flows? That's a genuinely hard question, and I'll be honest with you, it's one that physics doesn't fully answer yet. The experience of time flowing, the feeling of the present moment, might be something that emerges from the way consciousness and memory work, from the particular way our brains process information in one direction along the time axis. The physics describes the structure. The experience of moving through it is a separate puzzle. But here's what the physics does say clearly. The fact that you experience a moment doesn't make that moment special in some cosmic sense. It doesn't make the past disappear once you've moved past it, any more than Los Angeles disappears when you fly to New York. Think about that for a second. You're standing in New York right now. Is Los Angeles still there? Of course it is. You can't see it from where you're standing. You can't interact with it right now. But it exists, completely and fully, at a different location in space. Now apply that same logic to time. You're at a particular moment right now, this Tuesday afternoon or whatever it is for you. Is last Tuesday still there? According to the block universe, yes, it exists at a different location in space-time. You can't visit it. You can't see it from where you are in time. But it exists, fully and completely, at its coordinates in the four-dimensional structure of space-time. Every moment you've ever lived is a location in that structure. Your first day of school is there. Every conversation you've ever had is there. Permanently, geometrically, not as a memory, not as a recording, but as an actual physical region of spacetime with the same ontological status as the region you're currently occupying. Now let's talk about what happens at the end of a biological life. From an everyday perspective, we say a person dies and they are gone. From the perspective of spacetime geometry, what actually happens is this. A human being is a long, continuous tube of events drawn through the four-dimensional block. It starts at birth, curves and twists through childhood, education, relationships, experiences, and it ends at a particular set of space-time coordinates, the event we call death. But that tube doesn't retroactively disappear from the block. The coordinates of a person's life are fixed in the structure of space-time. The beginning of that tube is just as real as any other part of it. This is not speculation. This follows directly from the mathematics of special and general relativity. The coordinates of past events don't get erased. They are not somehow less real because you can no longer access them from your current position in time. Reality is not a movie that stops existing once you've watched it. It's more like a book. The pages you've already read are still there. The words don't disappear just because your eyes have moved on. Now here's something even more striking. Because of the relativity of simultaneity we talked about earlier, different observers moving at different speeds will disagree about what now means. An astronaut moving away from Earth at a significant fraction of the speed of light would point to a moment far in your past and say, "That is happening right now for me." Another observer moving toward Earth might point to a moment far in your future and say, "That is my present." The window of now that different observers share is actually surprisingly thin. And for observers separated by large distances and moving at different speeds, their nows can be millions of years apart. This has a strange implication. From the reference frame of some distant observer moving at a different velocity, events from your childhood are genuinely happening right now, not metaphorically, not poetically. In the precise mathematical sense, that relativity defines simultaneity. Your past is someone else's present. Your future is someone else's past. The block universe isn't just a convenient way of thinking about things. It's what the equations actually describe. Let me give you another analogy for the space-time tube idea. Take a candle, light it, watch it burn for 5 minutes and then blow it out. Now here's a question. Does the flame that burned at the very beginning of those 5 minutes still exist? In the everyday sense, no, that particular moment of flame is gone. But in the space-time sense, the region of the block that corresponds to the candle burning at minute 1 is just as fixed and real as the region corresponding to minute 4. The geometry doesn't care about before and after in any absolute way. Those are just different addresses in the four-dimensional structure. And now here's the deep physics of why it feels like time only moves in one direction, even if the block universe is symmetric. The laws of physics, the fundamental equations, are mostly symmetric in time. Run them forward, run them backward, they work the same way. But there is one quantity in the universe that consistently increases in one direction, and that's entropy, the tendency of systems to move from more ordered states to less ordered states. A glass falls off a table and shatters. You never see all the shards spontaneously reassemble into a glass. Not because the laws of physics forbid it, but because the number of ways things can be broken is astronomically larger than the number of ways they can be intact. The arrow of time, the sense that the past is different from the future, comes from this asymmetry in entropy, not from anything in the fundamental equations of motion. This means time's one-way character is a statistical phenomenon, not an absolute one. It's a feature of large-scale physical systems with many particles. At the level of individual particles, the physics is time reversible. An electron interacting with a photon doesn't know which way time goes. The directionality we experience is an emergent property of enormous collections of atoms behaving statistically. And when you trace a human being down to their fundamental components, they are an enormous collection of atoms with an enormous amount of internal complexity. The biological processes that sustain life are highly ordered, low-entropy configurations. As they run, they produce entropy, they generate heat, they consume organized chemical energy, and release disordered heat and waste. Life is a temporary region of high organization embedded in a universe that is generally increasing in disorder. But here's what's interesting. Those atoms don't disappear when a biological life ends. They don't stop being part of the universe's accounting. They get redistributed into other forms, other configurations, other low-entropy pockets that are built and maintained by the same relentless thermodynamic processes. The carbon, hydrogen, oxygen, nitrogen, all of it, continues participating in the universe's ongoing evolution through phase space. The person, as a specific configuration, as a specific set of spacetime coordinates, ends. But the ending is a coordinate in the block, not an erasure of what came before. And the stuff that made up that configuration continues participating in the universe's ongoing physical story. Now, I want to come back to something that I think is the most mind-bending implication of all of this. We've established that different observers disagree about simultaneity. We've established that the block universe is a four-dimensional structure where all events coexist geometrically. Here's the implication that follows from those two things together. There is no absolute fact about what is happening right now in the universe, not even in principle. The universe doesn't have a master clock that ticks out a universal present. It has a four-dimensional geometry in which every event exists at its coordinates, and the way you slice that geometry into past, present, and future depends entirely on how you are moving. This is radical. This is not a soft philosophical position. This is what general relativity and special relativity tell us in unambiguous mathematical terms. The present is not a cosmic fact. It is a perspective. And if the present is a perspective, then the past is not a void. The past is a region as fully real as the region you currently occupy. The future is not a blank. It is a region that exists in the block just as surely as the city you drove through yesterday still exists, even though you can no longer see it in your rearview mirror. So when we look at the beginning and end of a human life, what physics actually describes is this: a structured tube of organized matter moving through four-dimensional spacetime, maintaining its configuration against entropy for some number of years, and then reaching a coordinate where that particular organization can no longer sustain itself. The tube has a definite length in the time dimension, but that length is a fixed fact about the geometry of spacetime. It doesn't get shorter. It doesn't disappear. It is simply a feature of the block with specific coordinates, a real physical structure that exists as fully as any other region of the universe. The ticking clock you looked at the beginning of this conversation is just measuring the rate at which you move through this structure. Each tick is not destroying the previous second. Each tick is just moving you to a new address. The second you just left is still there at its coordinates, every atom of it, every event of it, exactly where the mathematics of spacetime says it has to be.